going to uh, discuss regarding the eQuEST versus IESVE. So first question to Arihant, and it is on eQuEST. From your hands-on experience on eQuEST, how would you explain building energy simulation to the construction professional who has never used such a tool?
So I'm presuming that the energy professional understands what energy simulations are. So I
Mhm,
would explain them more like a spreadsheet-based software, and to not get overwhelmed with its interface because it looks very different from all other softwares. But
mhm,
it's not that difficult. Once you get a hang of it, it is very fast and efficient, and I would say like one of the fastest in the industry.
mhm,
Also, if you want to delve deep inside, you can also go into a separate file called .inp file and change multiple inputs with just like a find and replace option, which is similar to like a some doing something in a Word document. And once you understand what's going on here and there, it's not that hard to grasp, and it's a best software I would say to start off with, as it is uh, relatively easy. I wouldn't say it's the easiest, but it's also like quite fast and efficient.
okay. Thank you. Next question is to Nicholas regarding the ISV. So, Nicholas, while using the ISV, would you describe simulation in a similar way, or does it is beyond just energy modeling?
Uh, IESV, I think it's a little bit, I wouldn't say complicated, but yet it is a very powerful simulation software with lot of capabilities. I think in properly in energy simulation, you can like create models and geometries like in a real case scenarios. You can replicate those complex facades, complex geometry in IES. Also, if you have models created in some other software, like a design software, for example, SketchUp, Rhino, which generate designers use, you can replicate or export those models directly in energy simulation software like IES, which I think gives you a little bit advantage and saves a lot of time in modeling the geometry from the scratch. And also it has a lot of capabilities working for example in the HVAC systems, a lot of options, a lot of new upcoming HVAC systems which have come up in the market, all have been incorporated in the IESVE software, and it helps you to predict a real case scenarios with the systems, with the modeling, and how the geometry will look like, how the systems will operate. So all these gives you a little bit benefit in analyzing and understanding the building, how it will perform over the time. So I think, yeah, IESVE also has some really cool advantages and features included in their packages. Apart from, for example, doing not only energy simulation, but you can perform daylight simulation in that same model which you have imported, and you can do a thermal comfort, you can do a compliances in the same software. Uh, so yeah, I think IESV holds a little bit advantages over those situations where you have a complex buildings and you have an already models created by the designer. You can directly import those things in this ISV software.
Okay. So I have open question to both of you. Do you see simulation mainly as a design stage activity, or should it also guide decisions during constructions?
Uh, I can go on this. So I believe, yeah, it could be both ways, and it should be both ways. It should be used at both the stages. So at early design stage, it helps you decide certain things, like orientation of the building, the material selection, and everything. And during the construction phase, also, you need to ensure that what you selected in the energy modeling, what you decided at that moment, those selected things are implemented in the projects, and if during the construction there are some changes due to budget constraints or any other reasons, you can select alternative materials and options and try and simulate them, and then select the best one for your needs as per your requirements, whichever fits your needs. So it should be used at almost like every stage of the project to make wise design decisions.
So have you used simulation for any operational building or existing building, and how it is different from using doing simulation during early before construction and after the construction?
So I have used simulation for before the construction, after the construction as well. So usually what happens is before the construction, we simulate it when we need to make design decisions and other decisions which help us in selecting materials, in selecting the building orientation, in selecting passive strategies, in selecting equipments. Whereas for the existing buildings, we usually create energy models and we try to understand their energy performance, what's their current energy performance. So in that scenario, it is very important to calibrate the building as close to the energy performance of the actual building as possible. There's
Okay.
all there. So we need to know that it is just a prediction tool. The energy simulations are a prediction tool, and
Mm-hmm.
they are used for comparison and not for individual performance. So we always talk in percentage savings as compared to something else. We just don't say like, okay, the thermal performance of the building is this much, so it has to be exactly this much. This will not
Mm-hmm.
happen. We
Okay.
always say that, okay, this is the percentage difference. So that's how it differs at the different stage of the buildings.
Okay. Okay.